Hello everyone, this is Priyadarshini and welcome to my video. Let's get started. Simple harmonic motion is my topic. Under that, we're gonna see compositions of two simple harmonic motions of same period. Here I have attached a simple animated diagram. Let us have a look to understand the concept in deep. Look at the x and y axis and see the blue and red dot, which is the two simple harmonic motions with same period omega t. Let us solve the bookwork 12.5. Show that the resultant of two simple harmonic motions of same period along the same straight line is also simple harmonic with the same period. Solution. Let the displacements in the two given motions be x1 is equal to a1 cos into nt plus epsilon 1 and x2 is equal to a2 cos into nt plus epsilon 2. This we get from phase and epoch. Then the resultant displacement is given by x is equal to x1 plus x2. Substituting this and using the cos a plus b formula, we get cos nt into a1 cos epsilon 1 plus a2 cos epsilon 2 minus sin nt into a1 sin epsilon 1 plus a2 sin epsilon 2. Mark this as equation 1 and let us consider the a1 cos epsilon 1 plus a2 cos epsilon 2 is equal to a cos epsilon. a1 sin epsilon plus a2 sin epsilon 2 is equal to a sin epsilon. Mark this both as equation 2. Substituting the equation 2 in 1, we get the resultant x is equal to a cos into epsilon plus nt, where epsilon is the epoch and nt is the time period, which is the resultant. Squaring and adding equation 2, we get a cos square epsilon plus a sin square epsilon is equal to a1 cos epsilon 1 plus a2 cos epsilon 2 whole square plus a1 sin epsilon 1 plus a2 sin epsilon 2 whole square. Using the a plus b whole square formula, we solve the right hand side and by solving we get a square is equal to a1 square plus a2 square plus 2a1 a2 cos into epsilon 1 minus epsilon 2, which gives us a is equal to root of a1 square plus a2 square plus 2a1 a2 cos into epsilon 1 minus epsilon 2, which is the amplitude. And also from the equation 2, we also get the epoch. Sin epsilon divided by cos epsilon is equal to tan epsilon. Tan epsilon is equal to a1 sin epsilon 1 plus a2 sin epsilon 2 divided by a1 cos epsilon 1 plus a2 cos epsilon 2. Keeping the epsilon left hand side and taking the tan right hand side, we get epsilon is equal to tan inverse of a1 sin epsilon 1 plus a2 sin epsilon 2 divided by a1 cos epsilon 1 plus a2 cos epsilon 2, which is the epoch. Here we can conclude that the resultant motion is also simple harmonic with the same period as the component motions. Its amplitude and epoch are a and epsilon. Thanks for watching.